Welcome to another episode on my fischertechnik robot hand with a pneumatic hand and a robotic arm. In robotics there are degrees of freedom which indicate in which way and in how many ways part of the robot can move. The degrees of freedom are being denoted in roll, pitch and yaw. Roll is what this wrist can do, so like this. Pitch is as the arm can do, like this, and yaw is what the arm base can do, turn around its base. Now, I've been asked on conventions, is this all the robot can do? Well, for now, yes, but the interesting thing is, of course, that the hand itself is quite flexible where it comes to the wrist. Well, I have this motor with the bipolar switch and I have this flexible construction so it can move. It would be nice if I could use a motor like this, which is the same type as this one, and some movement like this to actually put it here or like this or somehow here and make this connect to these points and actually motorize this. So the question is now, how can I do that? The point is, of course, that I need a strong motor, and since it has been proven that both this motor and this motor are necessary because of the heavy weight of the parts, I will probably need this motor for pulling the hand. Will this then suffice? Well, that's a nice new experiment. Let's see if this works anyway. And when I put it like here or this way, no matter how, I need to guide it, because if I don't guide it, it will immediately go like here and get stuck somewhere. So I need guidance here as well, apart from having longer wires. How will that work then? Well, of course, there's a chance that it needs another switch like this, and program it such that it just runs one way and electrically gets switched, or just really program it. And I think it's nicer to have it like this, just continuously do it in this way. Then I have to consider also this weight, because this is a counterweight for the hand. And in order not to put too much weight on it, I should put it on the elbow. So let's see how this ends up. And I'm very curious on the result, because this is just go as it goes, and so it has been since the rest of the development. So let's see. Right, with this winch mounted with a longer axis or axle, there is an option, or there are more options in controlling it. First of all, I put a mounting plate on the motor, and my initial thought was to put it like this. However, therefore I need a gear here as well. Controlling it may be easy, because I can wire it to this switch. So whenever this motor is controlled, this motor will be controlled. Easy solution. Another point is that I would need a gear here as well, because it needs to be driven by the motor, or the motor needs to drive it. Point is, that would be such a gear, which I don't have, and a very large gear like I have on other places would be like this, which is kind of oversized in this case. So I thought about a different idea, which is putting something like this, coaxial. So one on here, one on here, the motor like this, or vertical, also possible, but this would, in this position, would be a nice idea, and then it could be a nice solution. The only thing is that would this really fit? Well, not really, because it's not long enough. It needs to go in here. So that would mean that I would have to shift the whole axis, and for instance like this. And then have it in this way. And even then it doesn't really work. Let me see. No, I need to have it right up here. So despite the idea, what do I have then? If I have it like that, I would have to have an extension to the motor, because this spindle is too large for this part. So I'll have to figure out some more things, and even with this I would have to put the motor right here somewhere. So as usual, initial ideas may work out, but in different versions. And with this, will it even work when I completely... I can't get the winch further away, but let's see, just for testing. Alright, this works. So now it grips on it, and that's a nice idea. So now it's really here more than halfway in. If I can get this to work, it would be a nice idea. Extend this, put the wire to the motor, and have the motor like here. Otherwise, I have no idea how that would work, Oh, and including some guides to guide the wire along here. So that's for thinking, and now for some execution of an idea. Right, with this fixed, I had to change the motor setup with a combination part, and on top this, and it is really completely through, otherwise it wouldn't even stuck. Unfortunately it is not a metal axis but plastic one, which is flexible in itself. And then how do I fix it? How do I mount it? Well, here I have one half block mounted, and the idea is to do it like this. So in comes this piece, where I put this in. So initially this will slide in here, and then this will go like this. At least that is the idea. And then how further? This proves already to be too flexible, but it's also about distance. And then I found out that this won't work this way. So I actually should put it the other way around. So like this. And then shift this in somehow. Alright. In itself a very nice idea, but as you can see it is way too flexible. So in the same idea that this has been too flexible, I need to come up with an idea here as well, before I even think of connecting this all and wiring it here. But how to fix this? That's a very good idea, very good point. And even if I fix this, will this be good enough? I've done this before, and then you see that when I hold the motor, this is flexible. So will this ever work? I don't know. Probably it will kind of end up in that way, like I've done it with this, where this is the same situation, only I have put here an ending, so it is one long piece, which takes away the flexibility. So I may have to do the same trick here. The question is though, is it strong enough? And now I already see that this is going to slide. So all in all, yeah, a nice idea, but will it ever work out? I don't know, we'll have to see. I have longer axis, and then put something here to hold the axis. Interesting. So to hold it, I constructed this piece, which would go in here. Let's see. First in goes. And that's not possible. Alright. That's an error. So I need another one of this. And not another one of this way. So in comes this, then this one should go in. However, the axis, or this way, is maybe more appropriate, but then it's not high enough. So this one has to be replaced by a longer one. And then see what happens. That will just go. And then the correct height. This should give strength enough. Well, it still moves around. And that is because of this point. And once again, looking down here, I solved it by putting two of these small blocks and putting it like this. And this is resting on the plate. And I don't have this advantage in the elbow. So I don't have a plate here, and I should have another one like this right here to avoid, for example, this, because this will happen. But that's just another challenge to a new idea. And how to solve it, that's another question. But no doubt I will find something to it. Question is what? And that is a very good one. I don't know yet. Of course, I can connect all these elements to create strength, and that may be a solution. If it is the solution, I don't know. It has to fit in here as well. So maybe another one of this construction in here, and then connect everything. Sounds like a nice idea. So one goes in here. And then another construction in between. Let's try that. Right, so I've put another one up here. Let me move the camera a bit to maybe show it a little better. So now I have two connecting pieces here, which improves this a bit. And let me put this here. So that's one thing. It just needs a connection here with this maybe. Or I can just make a connection now and see how it works. Also possible. And the question is, do I have a wire that's long enough? Let's see. No, that's by far not long enough. So that is going to be another challenge, how to wire it up and how to safely wire it. That's another question, because this wire is running from here, so I actually should not wire it from this point. Oops, I shouldn't wire it from here, but from this point, since this is going to the motor. Oh, then it is long enough, because I can wire it from here. Let's try that. So, taking off this one, connecting it, and taking off this one, connecting this one too. And I can easily wire this again, or should be able to. So it may not be that easy. One. And two. And here. One and two. So this is wired. And let's see how the connection goes. No, it's not wired. Now it's wired. Yeah. That will be alright. So in this way it is wired and I can test it. So let's just do that. Testing. I can run the program for it. No diagnostics needed. So let's just see how it runs. And different angle. Alright. Just see. Ah, right, the arm moves of course. But yes, you see it move all along. Which is very nicely wired indeed. Will it have the strength to keep it up? I don't know yet, but that's only something we can see in reality. last part for this episode. Apart from the current situation, I still have to do the axle, of which I doubt that it will carry the weight of the hand, since it is a problem with the old walking model Merft as well. How about the rest? We'll have to see. Longer wires or other wires, it's all for next episode. For now, it's a nice construction. Thank you for watching. If you like this video, please subscribe to my channel, give it a thumbs up, leave a comment. Also follow me on Twitter, retweet and like, follow me on Instagram and like, leave a comment. Please donate to keep videos coming to you. More information at the start of this video and on my website. Very much appreciated. And this is of course going to be continued with the stabilization of the motor, experiments with the axle and the winch, extension of this, of the wires, guides, maybe rewire, and checking with the software. Once again, thank you for watching and bye bye.